All right, so these are going to be the notes for multiplicity, and then we'll do graphing the next day. All right, so first off, we're going to talk about zeros. Those are solutions of a polynomial function. So they're the x-intercepts. It's where the graph crosses or touches the x-axis. And it's fairly simple. It's what we've been doing like kind of the whole year. You set the function equal to 0, and then you solve it for x, okay? So I'm going to read through the definition of a zero. It says, if f, the function, is a polynomial function, then the values of x for which f of x is equal to 0 are called the zeros. And once again, zeros are where they cross or touch the x-axis. These values of x are the roots or solutions of the polynomial equation f of x equals 0. Each real root of the polynomial equation appears as an x-intercept, so it means it crosses or touches the x-axis of the graph of the polynomial function. Okay, so examples 5 and let's go through that first. So it says to find the zeros. Now this one's a little bit different. We did this a while back, but I'm going to kind of show you how to do it. So first off, to solve it, we're going to make sure we set it equal to 0. So f of x, we're changing that pretty much to 0. Now this one, you'll notice there's 4 terms. So we're going to actually factor this by grouping. And it's been a while since you've probably done this, so do pay attention. So when there's 4 terms, we're going to group the first 2, and then we're going to group the second 2. Then for the first 2 numbers, we're going to look for the greatest common factor. So when we look at x cubed and 3x squared, we know they're both divisible by x squared. And I'm going to divide each term by x squared. So when we divide, we subtract exponents. So x to the third divided by x squared. So 3 minus 2 is 1. So in parentheses, we have an x to the first power. 3x squared divided by x squared. This turns into a 1. So I'm just left with the positive 3. All right. From the second group, I see they both have a negative sign, and when you're factored by grouping, if you recall, the parentheses have to be the same. So what I'm going to do is I'm going to factor out a negative sign, which can become negative 1. And if I divide this by negative 1, negative x divided by negative 1 is x, and negative 3 divided by negative 1 becomes positive 3. And hopefully what you notice is that the x plus 3's are the same. So the common factor between these 2 terms is the x plus 3. So we're going to take x plus 3, put it out in the front as 1. And then in the second set of parentheses, whatever is left outside of our x plus 3, which in this case is x squared minus 1. All right, and make sure we are setting this equal to 0 because we are going to solve it. And then the last thing, x squared minus 1 is a difference of 2 squares. So we have talked about this before, but in case you've forgotten, I'll show you. So this is going to be x plus 3. Now x squared minus 1, if you wanted to do the x method, you could, but if you remember the shortcut, and you will see this again, so the shortcut is going to help. Since this is a perfect square and this is a perfect square, the square root of x squared is x, and the square root of 1 is 1. The first one we make positive, and the second one we make negative. Now, these are our factors, x plus 3, x plus 1, x minus 1. But since it's asking for the zeros, it wants the solution. So what I'm going to do is take each one, set it equal to 0, and solve. And if you can't do this in your head, then you probably should set them equal to 0 and work it out. So for the first one, I subtract 3. And x is equal to negative 3. There's my first solution. For the next one, we subtract 1 from both sides. X equals negative 1. And for the last one, we add 1 to both sides. And x is equal to 1. So those are my 3 zeros of this polynomial function. All right, for checkpoint 5, you can try it on your own, pause the video, but I'm going to work it out, and you can kind of verify your answer is correct. So just like before, we're going to find the 0, so we're going to change f of x to 0. And since there's 4 terms, we're going to attempt to factor by grouping to see if that works. So we put parentheses around the first 2, parentheses around the second 2. Now with x cubed plus 2x squared, we see they're both divisible by x squared. So I can divide this by x squared and this one. So x cubed divided by x squared is x, so parentheses x. 2x squared divided by x squared is positive 2. Second set of parentheses, once again, we want it to be x plus 2, so we see they're both divisible by negative 4. So let's put that on the outside. Negative 4x divided by negative 4 is positive x. Negative 8 divided by negative 4 is positive 2. All right, again, we notice these are the same. So we put that in front. That's our common factor, x plus 2. Whatever's left, we put in the second set of parentheses, so x squared minus 4. And just like before, the previous one, we had a perfect square, or a difference of two squares, x squared minus 1, which turned to x plus 1, x minus 1. Over here, we have the same thing. X squared minus 4, perfect square, so this becomes x. Square root of 4, it becomes 2. 1 positive, 1 negative. And hopefully you notice that we have 2x plus 2, so we could actually write this as x plus 2 squared times x minus 2 is equal to 0. Again, if you cannot solve these in your head, you want to set each one equal to 0. Now the squared, we don't really have to worry about it right now. If you write it twice, you're going to solve and get the same answer. So we're just going to set one of them equal to 0, x plus 2 equals 0, and then this one will set equal to 0, x minus 2 equals 0. So on the first one, we subtract 2 from both sides, and x is equal to negative 2. And the second one, we add 2 to both sides, and x equals positive 2. And again, if you split this into two of them, you would get x plus 2 equals 0, x plus 2 equals 0, and when you work it out, x equals negative 2 for both of them. All right, so that's how you solve factor by grouping. For the next one, we have 3 terms. So it says, again, to find the zeros. So for this one, we're going to factor it through the greatest common factor. So if there was 4 terms, I would group them. But since there's not 4 terms, I'm going to look at all 3 of these terms and see what they're all divisible by. So first off, I notice they all have an x. And we want to keep the first term positive. So when I look at this, I see they have negative x, and we have 4, 3, 2, so we pick the power of 2. So our GCF is negative x squared. So we're going to divide each one by negative x squared. Parentheses, a negative divided by negative is positive. X to the 4th over x squared, so 4 minus 2 is 2, so we have x squared. 4 divided by negative 1 is negative 4. X cubed divided by x squared is x. And then negative divided by negative is positive. 4, and x squared divided by x squared is 1, so it's just the 4. All right, from here, I'm going to take this trinomial and try to factor it further by doing the x method. So if you recall, b goes on the top. We divide by a. In this case, a is 1. And then a times c, so 1 times 4 is 4. So I'm looking for 2 numbers that add to negative 4, but multiply to 4. In this case, it's going to be negative 2 and negative 2. All right, so when we're doing this one here, we can write it as negative x squared. Now, if they're both going to be x minus 2 and x minus 2, I could actually write x minus 2 squared. All right, and I am going to solve this. So notice I set it equal to 0. So we set each term, or each factor that has an x equal to 0. So negative x squared, we're going to set that equal to 0. And x minus 2 squared, we're going to set that equal to 0. And notice I just got rid of the squared because I know it's just going to be one solution. So for the first one, you notice it has a negative sign. We're going to divide both sides by negative 1. So we get x squared is equal to 0 divided by negative 1 is 0. To get rid of the square, we take the square root. We can put plus or minus, but since it's a, well, I'll put it, but since it's a 0, 0 is not positive or negative, so pretty much x just equals to 0 for the first one. And for the second one, you're going to add the 2. And x is equal to positive 2. So you would come up with 2 solutions that are positive 2, which is just write one, that's good enough. All right, for this checkpoint 6, thing I notice is that there's only 2 terms, and they both have x squared. So automatically, I feel like the GCF is going to be x squared. So let's put that in front. So x squared is our GCF, and then we have x to the 4th divided by x squared is also x squared. And negative 4x squared divided by x squared is negative 4. Set that equal to 0. And then if you notice, this is another difference of 2 squares because perfect square minus sign. The square root of x squared is x. Square root of 4 is 2. 1's positive and 1 is negative. So this one's going to have 3 answers. So x squared equals to 0, x plus 2 is equal to 0, and x minus 2 is equal to 0. So for this first one, I just take the square root, plus or minus, but the square root of 0 is 0, so x is just equal to 0. For the second one, I subtract 2, and 0 minus 2 is negative 2, so x equals negative 2. And the last one, you add 2 to the other side, 0 plus 2 is 2. So x is equal to 2. All right, so that's how you solve for your solutions. Let's take a look at the next page. All right, for the next one, it's going to talk about multiplicity and the X-intercepts. And this is kind of getting along the ways of how we graph things. But let me go ahead and read to you what it says. It says, if R is a 0 of even multiplicity, so R is a solution, right, of even multiplicity, then the graph touches the x-axis and turns around at R. If R is a 0 of odd multiplicity, then the graph crosses the x-axis at R. Regardless of whether the multiplicity of a 0 is even or odd, graphs tend to flatten out near zeros with multiplicity greater than 1. Okay, so pretty much multiplicity is your exponents. Exponent of your factor. Okay. So right here, we're talking actually about the exponent, right? So if the exponent is odd, then odd multiplicity, your graph will cross the x-axis. If your multiplicity is even, then it will touch the x-axis and turn around. So it kind of like bounces. So wherever that solution is, it touches and turns, or it's going to cross the x-axis. All right, so let me show you how to do this. So for these here, we're going to talk about the solution, the multiplicity, and then we're going to talk about whether it touches and turns or if it crosses. So it says multiplicity, how many times a solution occurs, right? So a multiplicity of 1 means the solution occurs 1 time. A multiplicity of 2 means it occurs twice, 3 times, and so on. So like if I looked over here at these problems when I was getting like X method, so like this one, x minus 2 squared, the multiplicity is 2, which is even, which means that that answer shows up twice. But again, we only write it once, but it does show up twice, okay? So the nice thing about these ones here is they actually already factored for you, so you just have to figure out the solutions, right? So this one, I'm just gonna solve it in my head, or actually I'll write off to the side. X plus 3 is equal to 0. Subtract your 3, so x equals negative 3. So in terms of my solution, x equals negative 3. For my multiplicity, we're going to look at the exponent. So the exponent is 2, and that number is even, okay? And then last, we're going to talk about what happens in terms of at the x-intercept. So 2 things happen. If your multiplicity is even, the graph touches the x-axis and turns around, so it touches and turns. For odd multiplicity, the graph crosses the x-axis. So right here, we're going to say this one touches and turns. So it touch and turn. For the next one, we're going to solve x minus 5. It's cubed, but we're only worried about x minus 5 equals 0. We add the 5 to both sides, and x equals positive 5. So for this one right here, x equals 5. That's my solution. The multiplicity is right here, it's 3, and that number is odd. So I refer over here, odd multiplicity, the graph crosses the x-axis. So even touches the x-axis and turns around. Odd crosses the x-axis. All right, and for our last one, we actually have 2 of them. So for our first one, x minus 4, if I set that equal to 0, that would be x equals 4. For the second one, x plus 1 equals 0. If I subtract the 1, x equals negative 1. Now for x minus 4, there is no number there, so we assume it to be a 1. So the multiplicity is 1, which is odd. For the second one, we can see it has a power of 2. So for x plus 1 equals 0, x equals negative 1, the multiplicity is 2, and that number is even. And then how I actually write these when I'm talking about whether it touches and turns or crosses the x-axis. So for this first one, odd, it crosses. So I'm just going to put a C for crosses the x-axis. And for the second one, it has even multiplicity, so it touches and turns. So just T and T. So it touches and turns at the x-axis. Okay. All right, moving on to the last one. So for this last one here, example 7. It says find the zeros and find their multiplicities. So find the zeros of f of x equals 1/2 x plus 1 times 2x minus 3 squared, and give the multiplicity of each 0 and state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. Okay, so I'm going to solve these individually. So let's write, we'll do solutions right here, multiplicity, and at the end I'll talk about whether it touches and turns or crosses the x-axis. So for my first one, I have x plus 1 equal to 0, subtract the 1, x equals -1. For the second one, 2x minus 3 equals 0. First, we add the 3, so 2x equals 3. Then we divide by 2, and x equals 3/2. So my first solution is x equals -1. My second one is x equals 3/2. Now, for x plus 1 equals 0, the multiplicity right here is a 1, which is odd. And if you recall from the previous directions, if it's odd, it crosses the x-axis. For my second one, x equals 3/2, the multiplicity is 2, which is even, and it's going to touch and turn at the x-axis. Okay, and it is that simple. So once you solve it, you look at the exponent, was it odd or even? And if it's odd, it crosses the x-axis. If it's even, it touches and turns at the x-axis at that x-intercept. All right, and for the last example that you would have tried on your own, here we have this equation. Again, I didn't know if I talked about the first one, but the 1/2 does not have a variable, so I cannot solve it. Like right here, -4 doesn't have a variable. It may be a factor, but it has no variable, so I can't solve it. So this one, x plus 1/2 squared, so I'm just gonna write x plus 1/2, set that equal to 0 and solve it. So if we subtract 1/2 from both sides, x equals -1/2. For the second one, we have x minus 5 cubed, so we're just going to look at x minus 5, set that equal to 0. Add the 5 to both sides, x equals 5. Okay, just like before, we're going to write the solutions, the multiplicity, and then we're going to talk about, does it cross the x-axis or does it touch and turn? So for my first one, x equals -1/2. Right here, it has an exponent of 2, so that is even. So therefore, at the x-axis and at that x-intercept, it touches and turns. For the second one, we got x equals 5. And at this one, it's an odd, so 3 and it's odd. So at that x-intercept, it's going to cross the x-axis. And that completes the notes for today.